In this video, I'm going to use the washer method to find the volume given a ball of radius 18 centimeters, which has a round hole of radius 6 centimeters drilled through its center. Find the volume of the resulting solid. So let's first of all start by looking at this from a top view. So from the top, we have a ball, and we are drilling a hole through the center of it. So this is going to be hollow in here, and this is all going to be solid in through here. And that's basically what we want to do, is we want to find the volume of this solid region. To figure out how to do this, let's take a look at it from a side view, where we align the ball along the XY axes. So let's have the x-axis and the y-axis, or the x-axis and the y-axis, and our ball is going to be right about here. Nice perfect circle. Let's extend the y-axis up a little bit. And we can find the equation of this ball because we have centered this ball so the center is at the origin. The equation of this circle is x squared plus y squared equals the radius 18 squared, which is x squared plus y squared equals 324. Okay, I was just checking something there. Now, we are going to be drilling a hole. Now, we're looking at this from the side, so that hole is going to be going down from the top to the bottom. And all of this is going to be open in here. And our solid, the blue region, is going to be all of this in here and all of this over in here. And of course, this is going all the way around. Now, it would be easier to just take a look at the half of this. So again, from the side, let's just take a look. The y-axis and the x-axis over here. What we've got is our ball, and then we've got the hole drilled through it. And so our area is here. And you could think of this area right here as being rotated about the y-axis. And to do that, what we want to use is the washer method, where we have little sideways rectangles like this. Think of this little rectangle in here. And we're rotating that around the y-axis, and we would be creating a volume that would look like this up here. All right, so to do that, to use the washer method, we need an outer ring and an inner ring. So the outer ring is going to be the actual equation of the ball. But because our rectangles are sideways, we are doing this with respect to y. So that means that we're going to have x is equal to the square root of 324 minus y squared. Well, the inner ring is simply x equals the radius, which is 6 of the hole that's being taken out. There's x equals 6. This is the inner ring. So a rectangle, once again, is between the outer ring, which is this, and the inner ring, which is this. So now we have enough information, we can set up our integral. So the volume is going to be the integral, and so this up here, bounds of integration are along the y-axis. This would be positive 18 and negative 18, because the radius of the circle is 18. So we have 18 here, negative 18. And then we want the outer ring, which is the square root of 324 minus y squared. And we want to square that minus the inner ring, 6 squared, all integrated with respect to y. Well, we get rid of that square root very nicely. So we have the integral from negative 18 to positive 18. And we're squaring a square root, so we simply have 324 minus y squared minus 6 squared, or 36 dy. Now, another thing that you can do here is you could use symmetry, because the top half of this up here is symmetric to the bottom half. Just to save yourselves a little bit of time, you could use symmetry and say that the volume is equal to 2 times the integral from 0 to 18. And 324 minus 36 is 288 minus y squared dy. And now our integral is all simplified, set up, and ready to go. So volume is 2 times 288y minus 1/3 y cubed, evaluated from 0 to 18, or volume is equal to 576 y minus 2/3 y cubed from 0 to 18. And then plugging this into Desmos, we're going to end up with the volume being equal to 6,480. All right. Hope this was a helpful video.